What if I told you that there's a hidden world all around you? I mean, right beside you, right now. A world that exists inside every single atom, where the laws of reality are completely different from anything we know.
It's a place that seems, well, strange, even totally illogical. But here's the thing. It is fundamentally, undeniably real. Welcome to the quantum realm.
So let's take our first step into this bizarre world and try to figure out what exactly is going on in there. Okay, so quantum mechanics is basically the science of the impossibly small. We're talking about the building blocks of everything. Electrons, photons, protons. And down at this level, they just don't play by our rules. I mean, imagine a world where a ball could be in two places at once, or just tunnel straight through a solid wall. That's the kind of strangeness we're dealing with here.
And this leads us to probably the most mind-bending idea of them all. In the quantum world, nothing is certain until you actually measure it. A particle doesn't really have one specific location. Instead, it's just this cloud of probability, a whole range of possibilities, until the moment we look. It's almost like our act of observing it forces reality to pick a side.
Now, this built-in probability isn't just pure chaos. Oh no, it's governed by some very specific rules. And the first great law of this quantum land was laid down by the brilliant Werner Heisenberg.
Think about it like this. To see a tiny particle, you have to hit it with something, right? Like a little photon of light. But the very act of that photon hitting the particle to show you where it is, well, it knocks it off course, which changes its speed. It's this cosmic catch-22. The more precisely you know where it is, the less you can possibly know about where it's going.
And this is the crucial part. This isn't because our instruments aren't good enough. It's not a technological problem. It is a built-in feature of the universe, a fundamental law that says, nope, you're not allowed to know both of these things perfectly. Uncertainty is literally woven into the fabric of reality.
All right, so now we get to one of the central mysteries of the quantum world, the dual identity of, well, everything. Are the building blocks of reality tiny little balls, or are they spread out waves? The answer is kind of confusing.
In our everyday world, these two things are total opposites. A particle is like a tiny little marble. It has a definite spot. A wave is like a ripple on a pond. It's spread out, it's flowing. They seem like completely different things, right? Or so we thought.
It turns out an electron acts like both a particle and a wave depending on how you look at it. This was proven by the legendary double-slit experiment. Get this, when they fired electrons one by one at a wall with two slits, they created a pattern on the other side that could only be formed if each single electron went through both slits at the same time, like a wave, and then interfered with itself. Yeah, it's a paradox that has fascinated and totally baffled scientists for a century.
Okay, deep breath. We're now arriving at two of the most famous and profoundly weird ideas in all of physics. These are the concepts that really push the boundaries of what we think is possible. First up, superposition. This means a particle can be in a combination of all its possible states, all at the same time. The classic way to think about this is Schrödinger's cat. You imagine a cat in a box, and its life or death depends on a random quantum event. Until we open that box to look, the cat is in a superposition. It's a weird blur of both alive and dead. It's only our active observation that forces it to be one or the other.
But believe it or not, the weirdness doesn't stop there. Now we have quantum entanglement, a phenomenon so bizarre it famously made Albert Einstein himself really uncomfortable.
So imagine you have two coins that are magically linked. You give one to your friend, who then travels to the other side of the galaxy. The instant you flip your coin and it lands on heads, you know right then and there that theirs has landed on tails. That's entanglement. Two particles become linked, their fates intertwined, no matter how far apart they are. This instant connection is what Einstein famously called spooky action at a distance.
So, we've gone deep into this bizarre, counterintuitive quantum world, but why does any of this matter? Well, it matters because this weirdness isn't just some scientific curiosity, it's the engine that powers our entire modern world.
Seriously, from the lasers and Blu-ray players to the computer chips that power our smartphones, quantum mechanics is at the heart of the technology we use every single day. The way an MRI machine can see inside your body, that's a quantum effect. Even the incredible precision of your GPS relies on atomic clocks that have to follow quantum rules.
Let's just take solar energy.
The way a solar panel turns a single particle of sunlight, a photon, into a flow of electrons, electricity, that's a purely quantum phenomenon. We are literally harnessing the strange rules of this hidden world to power our homes.
So here's the bottom line. The device you're watching this on right now, its screen, its processor, the global network that brought it to you, it is a direct product of our understanding of the quantum realm. We are all living in a quantum-powered world.
In the end, quantum mechanics is so much more than just some abstract theory. It's like the source code of our universe. It's the beautiful, mysterious operating system that runs reality at its most fundamental level. And it has been proven correct by every single experiment we've ever thrown at it.
We've unlocked so much of its power, but really, the journey has only just begun. What other secrets does this incredible realm hold? Could understanding it be the key to unlocking the mysteries of consciousness, or maybe even the fundamental nature of reality itself? The quantum world is waiting.